Okay, so an experiment observing the growth of two germ strand populations finds these patterns. A of x is equal to 1.3 raised to the x plus 9. And the population of the second germ is represented by the function b of x, which is 1.3 raised to the 4x plus 1. And then it says which function best represents the ratio of the population of the second germ population to the first germ population. And so, sorry, I'm trying to get to my screen here. So which one represents that ratio? So this is a ratio is like a fraction, right? So the ratio, and you put the numerator. So when we say ratio, if I say 2 to 3, or 2 to 3 parts or whatever, that's like saying 2 over 3, right? So the thing they list first is the numerator of a fraction. So let's start there. So we want, basically what they want us to do is they want us to say b of x compared to a of x. All right, cool. So then we have this base of 1.3, all right? And that's raised to the x plus 9 all over 1.3, which is the same base, raised to the x. Oh, you know what? I'm sorry, I wrote that backwards. Up here, b is 4x plus 1. 4x plus 1. And then down here, a is x plus 9. Phew, would have got the whole thing wrong if I did it that way. Now we can simplify this because they have the same base. So this problem's kind of rigged up that way. So we've done one where we've added two functions, and we've done one where we subtracted two functions. In the last problem, we multiplied two functions. So now we're dividing. The top is being divided by the bottom. Now, you may not remember this, but when we did the rules of exponents, if I say b to the m times b to the n, if they have the same base, it's just b raised to the m plus n, right? And then another property of exponents is if I have b to the m divided by b to the n, that's the same as b to the m minus n, okay? So with that logic, this whole thing is the base, which is 1.3, and then I'm going to take my 4x plus 1, and I'm going to put that in parentheses, and then I'm going to subtract from it x plus 9, okay? So then you gotta remember to kind of push this through the parentheses. So that'll be a negative x and a negative 9. In other words, when I simplify this, I'm going to have 1.3, 4x minus 1x gives me 3 x's. And then 1 minus 9, right? Because when I push that negative 1 through the parentheses, I get negative x and I get a negative 9. 1 minus 9 is just negative 8. Okay, so to clean this up a little bit, basically b of x over a of x is equal to 1.3 3 raised to the 3x minus 8. So that we're just combining functions. Now, what's nice about this is when you graph these, sometimes you'll have like sometimes you'll have a graph where you have like a linear function, but then it waves. You can do like a manipulation of like a wave function like sine and a combination with a linear function, and then you'll get like a wave symbol that's kind of like a line. So that's what we're ramping up to if you're like, why would we add these functions? Also, there's a very important business model where you can have an equation that represents the cost to manufacture a product, and then you have a function that represents the profit that, well, not the profit, but the income that you could generate with a product, and then you would combine those two functions to figure out your profit. And then there's a whole bunch, and you can have a function that represents customer demand and your supply, and figure out how much